Hi, welcome to Shiko's SAT review series. And we are continue working on the unit, the statistics unit. And this is the second part of a statistics unit. We're going to talk about the probability and work several many problems related to the probability in the statistics. And before we can do our worksheets, I have a few concepts I need to review with you guys and give you kind of fresh your memory. So we're going to go over what is the margin error. Then we're also going to take a look at what is the events operations. So what do we mean union and intersection of the events? Then the other things here is kind of like the big topics. So we're going to talk about is the conditional probability. And then the last things here, we're going to show you what is the contingency table and how do you read the contingency tables, okay? So I think after those four concepts, you should be able to go over the worksheets quite, so shouldn't have any trouble with it. And for this part, we probably will need to divide into the two videos for that because the one video will be too long for the topic here. Okay, so now let's take a look at our first part here. Okay, so the first part here is what is the, okay, so what is the margin errors here? So let me write here. So the margin errors here. So this is the definition. What is the margin error? Margin error, just from its term, is what is the error you're going to make. So let me give you an example. So for examples here, if I say that currently I take a, I did a survey and I find out 25% of the population, they are smokers. Okay, so I said, hey, based on my survey, I find out 25% of the, the population are smokers. But we know this is a statistics, right? It's not exactly 25%. So the margin error will be said, I think my margin error is 3% here. Okay, so if I say, hey, my margin error is 3%, what's that mean? That means my estimate, the true population could vary from 22% to 28% of the populations are, they are like 22% to 28% of the population are smokers. So that's the error. That's what we call it, the margin error, because I cannot get exact the estimate. Of course, every margin error associate what we call is the confidence level. So when you say that, so for example, I said based on my samples here, I am 95% confident, then the whole city's 22% to 28% of the populations are smoker. Okay, so each margin error, they should associate with certain confidence levels here. But basically, the confidence error is just to tell you, if you have some estimate, then what could be the differences. So for example, and if I have another example, so here, so we said, hey, if I go to take a survey for a city, then I find the average annual income. So if I say, hey, I find the average annual income is like $65,000 for the families here. And now my margin error is like, let's say the $5,000. So what's that mean? That means I'm pretty sure, of course, with certain confidence levels, right? So like I said, I'm 90%. So it depends on your confidence level. Then your margin error will be different. But from the SAT point, we don't need to know the formula, say, hey, if I give you a certain confidence level, what is the margin error? No, we don't need to know that. The only thing we need to know is about what is the margin error mean and how do we interpret that, right? So like in here, the margin error is 5,000. What's that mean? That means I'm pretty sure based on the confidence interval, maybe I said 95% confident, I'm pretty sure, and this city's annual income for the family will be between 60,000 and 70,000. That's what we mean, the margin errors here. All right. Okay, so now the next things here, let's go here, right? So the next things here, we want to see the events, operations here. So the first events operation, we're going to talk about the union. And the typical, we use, this is A union B, and this is the kind of the symbol we use. So what is the A union B? So if I put a graph for you, so maybe you will get a better. This is what we call the Venn diagram. I hope some of you still remember, right? So this is A, this is B here. So A union B basically is you just what? You just combine them together. That's what we say is A union B here, right? Of course, when we do the problem, when the SAT, the exam, when they give you the problem, they're not going to tell you, say, hey, go to find A union B. You need to read those word problems and identify the keyword. So the keyword for the unit is what? Is or. That means A or B will happen. See here, that's what we mean, the unions here. And we're going to take a look at the, here is just a brief review, right? So when we go to the worksheets, and then I'm going to highlight each one, say, hey, that is what is this tell you. Okay, so the next ones here, we're going to talk about the intersections, right? So we say A intersect B. So we use this notation, this symbol is kind of like upside down U's, right? So what is the intersections here? The same thing, let me give you pictures here. So maybe from the A intersect B, what's that means? That means here, right? So it's the common part of A and B here. Just like the union, the intersect have also, what is that here? The intersect, the keyword is and. All right, so those are the two events operation. So the other ones here, we can call it a complement. So you can use the notations A, depends, some book, so it's A prime, or you can write like A, C here, all right? So it's A prime, or, depends, different textbook, and then they have a different way to write it, but the definition is the same here. So if this is your event A, right? So A complement, that means everything not A. So basically it's everything outside A. So the keyword for the complement is what? Is not. Okay, so if A is a smokers, then A complement will be not smoker. All right, so that is the one thing here we're going to be very careful here. So the next things here we're going to talk about is a conditional probability. So what is the conditional probability? The way we say this is the one. So we say A, then you use a line, is B here. So that's how do we read. So how do we read? Say, so like let's try to write what is this probability? This probability here is the probability of A happen, given that B happens first already. So that's what we mean that is what we mean the conditional probability. So this symbol we read as given. All right, so that's also the key word in the word province. When they say given, then you know that is the conditional probability. And what is the condition? This is the condition. So the event B is the condition here. So let me write you out the formula for the conditional probability. So this ones here will be PB, and this is P, A intersect B. And you will say, oh boy, that is pretty complicated, right? It's not, all right? So let me give you a graph, and I think from the graph, you will get a better understanding. So this is A, this is B's, right? So A given B's, right? So B is the condition. So think about it. That means given that B already happened. So that means this part is B happened, right? So B already happened. Given that B already happens, what is the probability A going to happen? Okay, so under the B already happened, what is the probability of the B? Is here, right? So that's why you say, okay, so now under the B's, right? So the B will be on the denominator. Then the top, just like these red ones here, right? So let's say under the B, A going to happen. So that is the common part of the A intersect B. So far, so good? Okay. And then the next things here we're going to talk about is the contingency table. So what is the contingency table? And the contingency table is a table something like this. They have two variables, right? So variable A, variable B here. So the variable A and the variable B could be, for example, A, so here it's gender, all right? So it's a male and the female. And the B here could be their political view. So you could have a conservative. Then you can have a moderator, right? So you can have a conservative, you have a moderate, or you have an extremist, right? So now you want to find under this contingency table, what is the probability, either, for example, if it's a female and a conservative, right? So that's what like these numbers here, that means this is a female and a conservative. If you add the terms together, so like these numbers here will be total, what is the conservative? Total, what is the moderators here? And so, like I said, this is a very quick and kind of the very fast review, and assume you learned this in your, I think this cover in your Algebra 2, you have one small chapter about the probability. So this is a kind of a very brief review. And then let's go to the worksheets, and I'm going to show you a few problems on the worksheets, and then I think it's going to make the sense here. All right. So now let me go to the leave here, and I'm going to the worksheets here. Okay, so here is my worksheets here. Okay, so now for the worksheets here. Okay, let's say here. So a researcher survey. Let me first, let's see any keyword, right? Okay, researcher survey a random sample of students from a large university about how often they see movies. Use the sample data. The research estimated 23% of the students in the population saw a movie at least once per month. The margin of the error is 4%. which of the following is the most appropriate conclusion about the student based on this estimate of the margin errors here? Okay, so for these problems here, even before we look at the possible, the answers here, so just like we say, I estimate is 23%. Then the margin error is 4%. That means it could be very either ways, right, for the 4% here. So they can be vary either way for the 4%. So what is this one going to be? Going to be 27%. And what is this one going to be? It's 19%. So that means for the certain confidence level, I can say, the 19% to the 27% of the population, they saw a movie at least once per month. Right? That's how do we interpret, right? That means I'm pretty confident with a certain level, 19% to 27%. So now let's take a look, okay? So which one is the correct answer? So the first one, they say it is unlikely less than 23%. What you mean unlikely? No, right? So the 23% is the center, right? So let's say at least 23%, but no more than 25% of the student. No, why is it 25? Right? So the 23, so then okay, so then the number C and the number D, they try to kind of confuse you. So let's say the researcher is between 19% and the 27% sure that most of the students see a movie. Okay, so no, it's not. It's when you say the researcher is sure, that means the confidence. So this is not their confidence. This is the 19 to 27 is the percentage of the students see the movie. So the D will be the correct answer because they say it is plausible, right? So that means this word here, like I said, in the SAT, they're not going to ask you to use the confidence level and to get it. So that means in a certain confidence level, that means it is plausible that the percentage of the student who see a movie is between 19 and 27. All right. So this margin error is so 23 is the center. That means the average estimate is 23%. That's the percent of the student. So it's not the how much I'm from the research point I am, confident about that, right? So it's not. So the D is the correct answer here. Okay, so let's take a look at the problem number 2 here. So this is the insect count for the 3 pesticide treatments here. So we said 3 colonies of insects was each treated with a different pesticide over 8 weeks to test the effectiveness of the 3 pesticides. So I have a colonies A, B, and C, and the pesticide A, B, and C here. And then each pesticides were applied every 2 weeks, all right, for those colonies here. And now they say here, so this one's here, they say which of the following show a decreasing in size every 2 weeks? Okay, decreasing in size every 2 weeks. So let's take a look. Okay, so for the colony A, so it's this solid, right? So we start with 18 and drop and drop and drop and drop. Oh, so I know the colony A, does show decreasing. Okay, so let's take a look. So it's B. Colony B show decreasing or not. This is here. Then, oh yeah, it drop a little bit. Then drop here. Then yes, drop a little bit and drop a little bit. All right, so the colony B is also. How about the colony C here? Colony C, the first one is in here, right? And boom, the second week, what? They jump to up here. So colony C is what? Is not our choices to have a decreasing trend. So it's A and the B's, right? So it's a colony A and the B's here. So what is the answers here? Is a C here. Okay, so now let's say which is the closest ratio to the total number of the insect. Okay, so I'm looking for is the total number of the insect for all the 3 colonies in 8 weeks to the total numbers of the insect at the time of initial treatments. Okay, so that means I'm going back to here, right? The total numbers of the insects in here, that means at 8 weeks. Let's see what is the total here approximately. Okay, so here, this is approximately to 20, right? Then plus this one is kind of approximately to 10. And this one is between the 40 and the 60, so it's 50. So it's about 80. Okay, so this is the at the end of the 8 weeks to the initial, all right? So let's take a look. The initial is this bar at week 0, right? So what is the total approximately to? This one is kind of 80. And so this is a little bit above 60, so maybe it's 64. And this one is a little bit below 60, maybe 56. So this one's here will be close to what? Close to 200. So let's say what is the ratio of the 8 weeks to the initials, right? So the ratio will be the 2 weeks is 80 to what? To the 200s. So you simplify it. Boom, boom. So you got 8 to 20, then divided by 4. So you got a 2 to 5 here. So the A is the correct answer. Okay, now let's see here. Okay, so let's say, so this is the survey results. Okay, the table above shows the result of the survey in which tablets users was asked how often they would watch video advertisement in order to access streaming content for free. Based on the table, which of the following is close to the probability that a user answer always, given that the tablet user did not answer never? Oh, wow, we see a keyword here. So it's given, right? So I know immediately for the givens here, what I'm looking for. I'm looking for the probabilities here, right? So let's see. We know the probability, this is a given, right? So we say it's the probability of the A given that the B. So now let's take a look also. During the review, I show you this is the probability of the B and the probability the A intersect the B's, right? Okay, so now let's see here, right? Given that the tablet user, okay, tablet user did not answer never, did not answer never. So this is what? This is my B. And this one's here, this one's here, the tablet user answer always. So this is what? This is my A's here, right? Okay, so let's try to write it, right, from here. So it's a probability, okay, answer always, given that, not answer, never, right? So based on this probability, it will just be the problem, not answer, never. And here, this is a probability always, intersect, not answer, never. Okay, and now let's see here, not answer. Remember we said operations, right? So not answers. So what is not answer mean? That means, you know, it's everything except answer, right? So not answers here. So remember, not answer, never. Not answer, never, right? So it will be everything except, right? So it's the 0.243 plus 0.135 plus 0.309, right? Okay, so this is, this 3 is not never, okay? And then now, the top is always intersect, not never. And remember, what is the intersect keyword mean? Intersection, the keyword is and, right? So that means always and not answer. So always and not answer. So it's only this part, right? So this is 30.9 because this is the common part between always and not answers, right? So I'm sorry, it's not a point 30.9, it's 0.309, right? So I need to change it to the, so it's 0.309 here. So if you put it into the calculator, and this one will give you something close to 0.44978. So it's very close to what? 0.45 here. Got it? So this is a very good conditional probabilities here. Okay, so the next things here, so it tell you, they say, hey, in a random sample of the 200 cars of a particular model, 3 of them have a manufacturing defect. At this rate, how many of these 10,000 cars of the same model will have a manufacturing defect? So I know the probability to get a defect is what? Is 3 over 200, right? And so then out of 10,000, how many defects? You just times the probability you're going to get a defect, right? So what is you have is 150 here. And you don't have to use this probability concept. You can use like, or, you know, like in the, when you're in the algebra, you can use the ratio concept. So you say 3 defect over 200 is equal to X defect over what? 10,000. So you will get the X equal to the 150 also. It's just same things here. Okay? Okay, so now let's take a look at these ones here. Okay, so the human blood, we have a different AB, ABO, and then we have RH positive and RH negatives here. So that's why this is the distributions of the blood types here. Okay, now let's try to read. We have any keyword. So if they say one of these people, okay, who is RH negative is chosen at random. So what is the probability that the person have a blood type B is 1 over 9. So what is the value of X here? Okay, so these ones here, they say, I already, so what is the first thing? I choose a person, right? So this person is RH negative. Given that this person is RH negative and it is blood type of the B, right? Then what is the probabilities here, right? So, okay, so let's see here. So this is what we say, hey, this is the type of the B, given that this is RH what? RH negative, correct? All right, so we say this is 1 over 9. I want to solve for X, right? So, okay, so now this is a conditional probability. So I know this one here is the probability RH negative. Okay, then here this is a probability B and RH negative, correct? All right, so the RH negatives here, right? So remember, right? So what is this intersection mean? Intersection mean and, right? So it's B and RH negatives here, right? Okay, so now let's take a look at these ones here. RH negative. RH negative will be what is RH negative will be here, 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 right? All these people are the RH negative. So it's 7 plus 2 plus 1 plus X. Okay, take a look here, top here. So it's a B and RH negative. So it's B and RH negative. So how many here? Is 2, right? So this is B and. So this numbers here is B and RH negative. So they said this is 1 over 9. So what is the X here? So this one here is 2 over plus 10 equal to 1X. Then you can do the cross product here. So it's 18 is equal to the 10 plus X. So X equal to 8. Okay. This is a very good problem here. So like that's why you said because in here you highlight say, if one of those person is RH negative, that means this already happened. This happened first. This person is RH negative. Then also this person have a blood type B. So what is the value of X here? Okay, number 6 here. Let's take a look here. Okay, so this table is showing what type of the food that was they are fed to the cat and the dog currently boarded at a pet care facility. Okay, so we want to see here is what fraction of the dog are fed only dry food here. Okay, so this is what we call is the contingency tables, right? So we have 2 variables. These variables here, this is different type of the animal. And these variables here, this is different type of the food here, right? So the one of the key things when you read the contingency table is to see which one you're going to put on the denominator. So the key word is off, okay? Okay, so keyword is off. So you say in here, so they say what fraction of the dog, right? So what fraction of the dog? So the keyword is off. So of the dogs, total how many dogs here? 25, right? Are fed only dry food, are fed only dry food, so it's 2. So it's 2 over 25 here. So like those type of problems is very easy, but they are try to see you know how to read a contingency table. So the key word for you see where is my denominator in order to find the probabilities, right? So looking for the keyword is off, right? So to see if you can identify that, all right? Okay, so now let's take a look at these ones here, number 7 here, right? Okay, number 7, this is another contingency table. So we say these ones here, we have 2 vitamin, 2 different things. One, you given them the vitamin therapies, right? Then one of them is just the sugar pill. So that means, hey, maybe it's psychological. And then these variables here is adult, so they get the code or not get the code. All right, so now let's read the problems here to see we can identify the keyword, what are the keyword they want us, to study for, all right? Okay, so we tell you the table shows the result of a research study that investigated the vitamin C therapies in preventing cold. So a random sample of 300 adults received either the vitamin C or sugar pill over a 2 weeks period. And the adults report whether they contracted a cold during that time, all right? Okay, so now let's see here. They say, what proportion of the adults who received a sugar pill, right? So who receive a sugar pill and receive a sugar pill reported a contract code. Oh, what's that mean, right? So that means, let's see, do I see that off? Oh, yeah. Here is that keyword off. So what the proportion of adults? So that means, right, I'm looking for the whole adults populations. Here we are we are surveyed 300. So they say, what the proportion of adults who receive a sugar pill and contract the code? who receive a sugar pill and a contract code. So it's a what? It's 33. So you simplify it, it's 11 over 100. Okay, so that is the answers here. Okay, now let's take a look at part B here, right? So, you know, the statistics part of problem in the SAT, the math part is pretty easy, but what you need to be careful is the wording, right? So the problem looks complicated, but it's not. So, you know, depends on you will be able to pick out the keyword or not, right? Okay, so like number 8, let's say a market researcher selected 200 people at random from a group of the people who indicated that they liked a certain book. The 200 people were shown a movie based on the book and then asked whether they like or dislike the movie. Out of the survey, 95% say they do not like the movie. Which of the following inference can appropriately draw from this survey? I personally, I don't, you know, I think the book is 10 times better than the movie. Every time, you know, you read a good book and then the movie is always disappointed, right? So this is, okay, so let's say that out of 200, 95% of them, they don't like the movie. Okay, so let's take a look at what will be our choices here. So let's say at least 95% of the people who go see the movie will dislike the movie. Huh? Okay, at least 95% of the people who go to see the movie will dislike the movie. Okay, so they said, okay, so part B is here. They say at least 95% of the people who read the book will dislike the movie. And they say it's 95% they dislike. But we don't know it's at least. At least that means more than 95, right? So it's not more than 95. It's not say 95% the people go to see the movie will dislike the movie. No, that's not what it said. They said the people read the book, and then 95% of them. It's not all the people go to see the movie, 95% of them will dislike. Okay, and then they said at least 95% of the people who read the books will dislike the movie. So this is almost right, but it's not at least, right? Because it says 95, so could it be a little bit more, could it be a little less, so it's not at least. Okay, C is obviously is not true, so it's most of people who dislike this book will dislike the movie. No, will like the movie. No, we did not say that. Okay, so part D is the correct one. Okay, so they say most of the people who like the book will dislike the movie. This is a correct statement because you know those 200 people, right? They really like the, right? So they really like the book, right? And then 95% of them, that means majority of them is here, right? All right. So also the part B is not truth here, is who read the book will dislike a movie. But in here, it's not just everybody read the book. This one survey is those 200 people, they do like the book, right? So the D is a correct statement. This one is a little bit tricky, but you need to be very careful about the wording here, all right? Okay, so let's take a look at number 9 here, okay? So the number 9, so this one's here, they tell you, the manager of an online news service received a report above on the number of subscriptions sold by the service. The manager estimated the percent increase from 2012 to 2013 would be double the percent increase from 2013 to 2014. So here, how many subscriptions did the manager expect to sold in the 2014? So this problem really not quite related to the, so this, but it's kind of like a little bit like a probability percent of the increase, right? Okay, so let's take a look here. So from 2012 to 2013, right? So the percent of increase, so percent of increase, it will be what? always use the phi AA0 minus the beginning, phi 600, then you put the initial amount on the bottom is phi 600. So the percent of the increase is 1/20. And then it says, from the 2000, it will be doubled percent of increase to 2013 to 2014, right? So what's that mean? So that means 2013 to 2014. What is the percent of increase? So the percent of increase will be 2/20, right? It's a double, right? So it's really 1/10 here. Okay, so now let's take a look. 2013, I have a 5AA0. 2014, I don't know how much I'm having, right? So, but I know the percent of increase is 1/10 is going to be equal to x minus 5AA0 equal to the 5 divided by 5AA0 is equal to what? Is going to be equal to 1/10, right? Then you can do the cross product. So you will say the 5AA0 is equal to the 10x minus 5AA00. Then you can solve for x. So the x here is 6468. Okay, good. I like those multiple choice questions. If you got the answer, then most likely you know it is right. Okay, so let's do one more problem, and then we will stop this video. We will continue the remaining one on the next videos here. Okay, so this one's here, they said the number of contestants, okay? So I think we saw this table before from the first part of the statistics package for the distribution and the summary statistics here. Okay, so this is the same 20 contestants on each of the 3 days, have 3 days, they answer the 5 questions in order to win a prize, okay? So they receive 1 point for each correct answer. So here's their summary data. Okay, so now let's take a look here so we can see any specific question they ask us. So let's say no contestant received the same score on 2 different days, okay? If a contestant is selected at random, what is the probability that the selected contestants receive a score of the 5 on day 2 or on day 3? Whoa, that's the first keyword I see. Given that, but I got another keywords, right? And so we'll say that a contestant receive a score of 5 on one of the 3 days here. Okay, so let's given that the contestants one of the 3 days. Okay, so given that the contestant receive a score of the 5 on one of these 3 days. Okay, so let's see, we have the 2 things here. So this one here is a 5, right, on day 2 or day 3. Given that 5 on what? One of the day, right? Okay, so this one's really good problems here. So one of the day, probability 5 on one of the day. What's that means, one of the day? That means it could be day 1, could be day 2, could be day 3, right? So this probability could be like one of the day, right? So that means the probability could be day 1, could be day 2, could be day 3. And the name here, this is a 5 on day 2 or day 3. Okay, so remember, if you see over, what is that means? That means unions, right? That means you add one of the day. That means it could be, so let's see here, this could be on day 1 or day 2 or day 3, right? So this is a probability on day 2 over day 3, right? Okay, so now, right, let's take a look here. So day 1, day 2, and day 3, right? So this is a 2 plus 2 plus 3. Right, so this is a day 2 or day 3, and we also say this the top here will be the intersect for the one of the day, so it still is day 2 or day 3. So day 2 or day 3 is what is here, right? So this is a 2 plus 3. So what is here is a 5 over 7. Okay, so that is our answers here, right? So this is the conditional probabilities here, right? So this one's here, this is a given condition, so it's 5 on one of the day. Then the top is 5 on day 2 or day 3. And in fact, the top, I skip a step here. So the top should be like this, right? So the probability day 2 or day 3 and right, so it's intersect, right? So one of the day. So the one of the day is day 2, day 3, and day 1, right? So intersect, like we talked before, the intersect means what? This intersect means end, right? Okay, intersect means end. So it's D1, D2, D3, D2, D3. So that's why we'll give you D2 and the D3. That's what I have here, D2 and the D3 here. So this is the, what we call this a conditional, right? So you need to see the keyword, right? So given that, given, right? So given that one of the day, so you know one of the day could be day 1, day 2, or day 3. And the top is day 2 over day 3, right? So over, that means unions, right? Over is union, that means you add them here. So the answer is 5 over 7. Okay, so now I think it's a good place to stop here. And then we're going to resume the video number 2 to finish the remaining problems here, right? So remember, right, when you do those statistical probability problems here, specifically when you have a contingency table, so which one you put on the denominator on the contingency table? So what is the keyword we're looking for? Off, right? OF, right? Then for the conditional distribution, what is the keyword we're looking for? Given, right? So for the given, that means that one will be on the denominator. That's the condition. That means that condition already happened. All right, and that's it. All right, so I'm looking forward and to talk to you on our next video so we can finish this package. And it's nice to talk to you, and you have a good day. And okay, so looking forward to talk to you in our next videos here. Okay, bye. Have a good day. Bye-bye.